So good afternoon, and thank you for joining us this afternoon. And our topic around building the connected battlefield for the tactical edge, and specifically, how we're transforming the mission and enabling decision making at the point of data collection. I'm John Pisano. I'm with Booz Allen Hamilton. I'm a principal in the firm's strategic innovation group. And with me today is Ben Reef, a lead associate and one of the technical architects and visionaries behind our Smart Edge reference architecture. So when looking at today's connected environment, we've seen this pattern of a proliferation of IoT and edge devices. And in general, this expansion has kind of created a shift towards edge operations. And so what I mean is this increase in just the number of devices and sensors and whatnot is generating a significant amount of data in our environments. But we're also seeing that many of the organizations that we work with continue to operate in like our old ways. And overall, this has kind of led to a gap in the data capture and decision making, if you will. And so when you think about that in the context of a warfighter or a first responder, time is of the essence and every second counts. And so we're really looking at how you use this technology in the edge to close the gap between data collection and action at the edge. So what do I mean by the edge? So many people that we interact with, to them, the edge is the edge of the IT enterprise, right? So the edge of my data center or the edge of my remote access capabilities or mobile capabilities that I've deployed, or even as far as, the edge of my cloud deployments or where my applications are deployed in the cloud. And for us, though, we define the edge as truly that far tactical edge, if you will, right? So the warfighter, the first responder, things that they're wearing in their setups that enable them to do their job. And so when we think about that and take that view, we kind of look at, where we are today and where we're heading and where we need to be tomorrow. So if you think about it today, we follow what tends to be a very centralized model, right? So on the left there's sensors that capture data. The data is pushed back to some kind of a central processing mechanism that then either, prompts an action or prompts a set of recommendations for something to do, whether it's a person or maybe an actuator or whatnot. And where we really want to get to is more of on the right, where it's more decentralized, where on the bottom right there, the sensors are not only collecting, but there's something that's acting on the data, right? Whether, again, it's taking an action or making a recommendation or providing information that somebody can act on right there at the edge. And so it's really about transitioning from this centralized model to more of a decentralized decision-making process where this exists in this cloud to edge ecosystem. So when I talk about it, this here shows kind of what we view as this cloud to edge ecosystem, right? And so it exists on this spectrum, if you will, to very fixed on the left to more truly at the edge on the right. And the reason why it's important to kind of look at this is as you move from fixed to a forward operating base / a tactical operations center in the center to being on the move to the edge, you need to think about how you operate in the spectrum, right? So at each echelon, you're going to go from really highly robust capabilities and connectivity on the left to intermittent in the middle, where you have your fob and you're on the move, to completely disconnected, sometimes for days or weeks at a time at the edge. And so as you look at that, you really need to think about, how do I deploy software? How do I update software? And then how do I synchronize my data? And not only that, how do I do it in a bidirectional manner, right? So how do I do it in a way that I'm collecting and acting on it, but data is able to get to my more fixed locations, if you will, for more downstream analysis, or even things that happen there that get pushed back out to the operator that's at that far edge operating. So now that I've kind of highlighted this ecosystem and this need, I want to transition it over to Ben to kind of talk more about the how do you move from more of a fixed world to this tactical edge. Ben?
Yeah, thanks, John. So now that we have an overview or an understanding of this broader ecosystem and really what some of the needs are, let's take a look at how each layer within that ecosystem really supports operations at the tactical edge. So starting at the far left, we have our fixed cloud infrastructure, right? This could be AWS, could be Azure, what have you. As we have here, this is where our mission application development occurs. It's the same stuff that we're all probably here typically used to. We've got our MLOps pipelines and our DevSecOps pipelines. But here, they've been slightly adapted, right? So here, there's a much greater focus, on building, machine learning models that are optimized, whether that be for performance or for reduced size or overall footprint. And from a DevSecOps perspective, right, we now need to account for the diverse set of hardware devices that are out there at the tactical edge. So it's no longer just commodity cloud-based resources, right? So here the focus is really on building minimal, streamlined container images, but also different flavors of those images, right? So again, building versions of container images that will support multiple specific architectures, right? So like ARM processors, for example, right? So so we need to really think about that in terms of our overall DevSecOps pipelines and kind of what we're building. Here we're obviously also leveraging Kubernetes to support our overall deployment and testing efforts. So this could be something like K8s, or also it could be something like Rancher K3s, right? If we want to use that smaller, lighter weight distribution to really more closely simulate what we'd be seeing out at the edge. And of course, once we do all of our automated tests and complete all of our security scans, et cetera, we push all of those images to a Docker registry that we have access to. Moving to the right, this is where we get to our tactical cloud nodes. And so as John mentioned, from an infrastructure perspective, this could be semi-fixed hardware that could be relocated from time to time, or it could be completely on the move, right? So this could be mounted into tanks, ships, planes, what have you. And so this is really meant to bridge that gap between the cloud and the tactical edge, and really starting to extend some of our cloud infrastructure. And so, with things like AWS Snowball Edge or Azure Stack Edge, this is hardware that we can use that's really fairly robust, and it can be suitcase sized or even small rack sized. But this is really, from a hardware perspective, is well suited to support this type of an architecture. And so sitting on top of this infrastructure, you'll see here we have localized Docker registries on each of these nodes. And so this helps us to support our automated deployment. And so in this scenario, when we are within range or we detect that we're connected to the cloud or have access to the cloud, we're able to actually synchronize these two registries and grab updates from the cloud. And and then we can use deployment policies to deploy across our tactical cloud cluster, using Kubernetes, K8s or K3s, whichever in this layer as well. So depending on the footprint that you're looking for, this again could be K8s or K3s as well. And using these different deployment policies and things like node labels, this also helps us to control how we deploy our containers across the ecosystem, right? So this could be based off of different metadata. So is it do we need to deploy a particular container on GPU accelerated hardware or just CPU? Or is this a container that's resource intensive that is really meant for the tactical cloud, or can it go at the tactical edge? So using different deployment strategies, we can really fine tune and control how we deploy our containers across this ecosystem using Kubernetes. Also, the types of things that are at this layer, we've got, so here we also have, obviously our mission apps, and from an analytics and AI perspective, we're still doing machine learning and AI here, but this might be more aggregate analytics, right? So really doing analysis and detections across the entire battle space, for example. And if and when we are connected to the tactical edge, it could be collecting data to feed into that, or to synchronize with the cloud at a later point in time. It could also be collecting metrics and statistics from the models running at the edge to do federated learning. So we actually do we're retraining the machine learning models here at the tactical cloud level, so we don't always have to wait until we get all the way back to the cloud to do this work. We can actually do some retraining out at the edge and support deployments updated deployments of those models across the ecosystem. And moving off to the right, we have our tactical edge nodes. And so this is, again, where we have, we're hosting some of our mission applications and machine learning models where we're doing analytics. And here, this is really probably more tactical machine learning algorithms here. So probably, analytics of specific sensor data, or it could be things happening in the environment around soldiers, or assessing different inputs from different data sources or UAVs, et cetera, overhead, or so really more mission-specific AI algorithms at this layer. Here deployed on all of our nodes, you can see again there's local container registries, but these are slimmed down. These from a size perspective, we only have the images that have for the containers that are actually need to run on that hardware, and also a limited number of copies, right? So we can do some rollbacks, but we don't want to have bloat there. But again, we use the same mechanism. We can detect when we're within range or when we're connected to a tactical cloud node. We can actually do updates and synchronization across those registries to pull down updates. And again, you can see we're using K3s here specifically instead of K8s, because again, we want that small footprint, streamlined distribution of Kubernetes across our cluster of edge devices here. And this K3 also helps us again with different deployment models. So we can do cloud to edge, or here tactical cloud to edge deployments. We can either push them out or do a pull model where the edge device decides when it wants to get those updates. We can also do an edge-to-edge push or pull. And so what this means is our tactical edge nodes don't always have to be connected to the tactical cloud. So they can operate independently on their own localized mesh network. And all we need is one of those nodes to be within range or connect to the tactical cloud, and it can synchronize registries and get particular updates, and then rejoin its cluster, and the rest of the tactical edge nodes can get the updates from it. Here you can also see that we have a multi-master configuration to provide high availability. So this is important at the tactical edge, where some of these edge nodes are going to be from time to time going in and out of range of each other and connecting and disconnecting to each other, depending on what's happening out in the field. So this really gives us some fault tolerance and some high availability across capabilities at the edge. And so, using this architecture along with Kubernetes and K3s and K8s, this enables us to really automate the deployment of new capabilities from the cloud all the way down to the tactical edge. And so now I want to shift gears a little bit and actually talk about the details of that tactical edge. So using this infrastructure, we've been able to deploy a software reference architecture for an edge computing framework, which we call Smart Edge. Now, this is just software, so it can actually live at any layer within this ecosystem. We've actually carefully designed it and optimized it to run on smaller resource constrained hardware. So it's really purpose-built to run at the tactical edge. So I just want to give you a quick overview and an orientation to what we're looking at here and what we have. So at the bottom, we have our external sensors. So that's what we're going to be integrating with and collecting data from. And as we move up the stack, you see we have Docker and K3s from a container management and container orchestration perspective. And then if we look in the middle to the left, we have our sensor gateway containers. So this is a series of services and APIs that help with doing sensor discovery and doing data collection and interacting with different sensors, capturing and exposing metadata about different sensors, and then really doing that lower level data and protocol mediation with the sensor. And really, so this really serves as an abstraction layer on for how we can actually easily plug in and talk to and integrate with different sensors and really hide all the low level details from the rest of the system. Moving up the stack, on the left, we've got our edge processing containers. And so this is really a set of different pluggable compute services and APIs. And so this also includes our model management APIs that allows us to update different machine learning models and load different machine learning models. We also have our inferencing engine, which can run those machine learning models against the sensor data that we're capturing. We also have some other services and interfaces around different types of processing compute. So it could be APIs around computer vision or natural language processing or digital signal processing, et cetera. As we move to the right, we have our switchboard. So this is really the layer that helps us with service orchestration and sort of integrating and orchestrating across all these different components and services. And this really helps us to create composable data flows for different client needs. It also helps us to do endpoints and protocol mediation when we need to talk outside, externally to other systems, and send sensor data to other systems. And then lastly, we have our mesh networking layer, our network intelligence layer that has a bunch of services and APIs around network discovery, APIs to send and receive data. So really an abstraction layer on different mesh networking technologies, so we can abstract that away. It also contains some capabilities around network monitoring and really optimization and intelligence there. So we can really determine what network do we use when we're sending different data. So this could be based off of metrics like signal strength or bandwidth, or it could even be based off of the type of data that you're trying to send and which network is most optimal for that type of data. And so as we look across this entire stack, there's really a few key enablers that have really helped to bring all of this to life. So one is just the fact of containerization and using containers. Right, this one obviously helps us in packaging and easing of deployments, but it also helps us to with the wide diversity of hardware out there. It really helps us to keep our services and components portable across many different devices and hardware platforms. Also, the use of microservices. That's also really helped us from an architecture perspective to decompose things into smaller chunks so that when we make updates, we no longer have to push the whole system or huge chunks of the system over the wire from the cloud all the way down to the edge. So it's allowed us to really focus on pushing smaller updates over the wire. It's also helped us from a modularity perspective, where we can, and deployment perspective, where we can actually pick and choose which components we want to deploy on a particular piece of hardware. So maybe we don't need all of the services. We only need to interact with a few different sensors, and we only need a few compute services. So we can actually, from a streamlining and from a footprint perspective, we've really been able to minimize that. And then lastly, from a container management perspective, K8s and K3s has really been a foundational piece and has really provided us capabilities to really help support really that automated cloud-to-edge DevSecOps capability, right? And it's helped us to provide, the ability to do updates with different deployment strategies, labeling and sort of customizing how we do those deployments across the ecosystem, as well as some scaling and high availability. It also gives us the ability to operate our edge devices in a clustered fashion, so really to support some distributed processing across devices. So that's a little bit about the technology. So now I'm going to hand it back over to John to talk a little bit about, what does that technology look like in a real life scenario?
Yeah, thanks. So now that you have an understanding of the need, right, and how we address it in our Smart Edge framework, now let's look at kind of how it comes to life, if you will, in a real world mission context. So to orient you to the mission here, so this is pretty common: military patrols and searching for high value targets. Prior to the advance of some of the technologies that we have today, a lot of how we accomplished that mission was, we'd have some kind of training or information that would be provided to us, whether playing cards with information about the high value targets, or some kind of identifying characteristics that we were briefed on, that then you would go out and we would do things like manually search for them as we were patrolling, or we'd set up control points where you kind of funnel people through so you can kind of look, and even as things became more advanced, we'd have things like retinal scanners where before you go on a mission, you'd load up the data and then you'd scan folks as you were interacting with them to see if they matched and whatnot. And so as you can imagine, just the logistical trail, if you will, of learning the information, having the information before you go out there, and the need to kind of be a little bit more dynamic, especially in today's environment. And so the value or the drive that Edge provides you is being able to send, service members or soldiers out into these patrols with these different sensors, some of which could be, like health monitoring, or some of them could be enablers such as a camera or an optical device to help reinforce what's going on in the space. But using those Edge sensors to basically augment the capabilities of the single soldier. And in a squad type setting, multiple soldiers who are connected in a mesh network. And so while on this mission, your edge kit, if you will, is set up with, and let's say an object detection model that's using the camera to look at the area surrounding and take it in and detect different objects. And the model is taught to do facial recognition and whatnot. And so as the squad and the soldiers are doing their patrol, the sensors can be used to scan as they're looking and moving throughout an area and taking in the objects and detecting them. And so what used to be a matter of you recognizing somebody by features that you were taught or looking for them, the camera is detecting it and alerting you that, hey, I've seen this object that you're interested in and whereabouts. And not only that, not only the person whose camera has identified it, but others in the squad being able to see that, hey, the high value target was seen by this soldier over here, and allowing them to kind of coordinate that response on how they want to deal with it, whether it's, detain the target or just monitor their actions. But more broadly, data that's collected during that point while they're acting on it locally, aspects of it being able to come back into the more fixed areas of the ecosystem, if you will, to allow them to do processing, a more broader look at what's going on there. So using those pieces in the ecosystem to enable that mission more in a dynamic manner. Or if there are things that are getting injected that maybe are changing the model, or maybe there's a vulnerability that's detected that's fixed along the way while they're on mission, being able to push that down through the ecosystem, has been alluded to, a microservice update, or maybe even a model update that triggers a reload of a container while we're on our way or while we're doing our mission. And so exercising that platform to do that. But if you take a step back away from the battlefield aspects, think about a disaster recovery type response where you have first responders on the ground that are trying to determine if they can safely go into a facility or a building that's been damaged during the response, and using edge type devices like drones or whatnot to use their sensors to do structural scans and provide recommendations on the structural integrity before the decision, before the responders make that decision whether or not to enter. But also that data getting pushed back to a command center where they're coordinating broader response efforts. So exercising that model and using it not only like in a digital battlefield perspective, but also like in a traditional humanitarian assistance disaster response scenario. So lots of applications that you could think of where you look at this edge technology and the use of K8 and K3 to enable that in those contexts. So at this point, usually, the question that we get often asked is, so where do we go from here? And so I'd like to hand it back over to Ben to kind of offer you some thoughts on, where do you go next in this journey? So Ben, back to you.
Yeah, thanks. So what's next, right? Where do you go from here? Or, if you've not yet begun your journey to Edge, how do you get there? And so, a few things I can think of are, one, I think we need to rethink some aspects of application architectures, right? So, one, obviously we need an additional focus on optimization and resource usage and a small footprint. That may be obvious, but I think also, a lot of us have been used to doing development and deployment in the cloud, and I think we need to sort of move away from this assumption of just sort of this always on, always connected, or just this we just have unlimited resources, right? Like that we have the luxury of in the cloud, and so we really need to think about and consider, how is my software or my component or my components going to handle a situation where we've got intermittent connectivity, right? Sometimes it's connected, then disconnected, then connected again, or even complete lack of connectivity, right? Or you may have the other extreme where hey, maybe we have multiple we're on hardware that has multiple connections or multiple network types or transports that are available to use. So how do we decide which one to use, right? Or considering we have to account for a much more diverse and resource constrained types of hardware that are out there for small edge devices. So just different considerations I think that we need to think about from that perspective, from a resource perspective, and then also I think we need to transition away from just our typical thinking around centralized computing, and putting a new focus on decentralized computing and really more real time and maybe even localized decision making. So maybe that means rethinking user or even system components or system interactions. So what is maybe that means rethinking the user experience when we get disconnected from other things. What happens? Or from a system perspective, we're all used to we have a centralized database that all of our services connect to. So maybe that means that, hey, guess what? We should shift to maybe using embedded databases, and we need to do more replication and synchronization, right? Or maybe we need to use a different programming model and do more event-based processing. And maybe we need to handle different events and data coming from different sensors or different conditions in the environment, et cetera. I think another aspect from an architecture perspective is maybe, and this is actually largely already happened or is happening, is moving away from monolithic applications and macro processing and services to really more microservices and more specific processing and services. And I think so. Those are some things from an application perspective, and then just from a broader development lifecycle perspective. It's just this whole situation around maintenance and sustainment, right? Once I have software deployed at hundreds of devices out in the field, how do I maintain them and sustain them? So really that whole process, and just start thinking about smaller, much more frequent updates, and how do you deploy updates across the entire ecosystem, and how many layers do you have, and what components, and thinking about what constraints do you have from a networking and a hardware perspective that you may need to consider, and then even from a runtime perspective, how do you synchronize that data from that raw data from the tactical edge all the way back to the cloud, right? Because the cloud isn't going anywhere. It's still a critical core piece of any enterprise and any organization. So just that whole development lifecycle and maintenance sustainment process, I think, is another key consideration and thing to think about here. And I think and to that end, I think that K8s and K3s has really been a key enabler for us to support that overall development and sustainment lifecycle for the tactical edge. And so John, those are just a few thoughts that I have of where to go next, how to get started, some considerations to make as folks move forward to think about edge and edge computing.
Great. Thank you. So thank you for your time today. We really appreciate it. And if you want to learn more about edge computing, we encourage you to visit boozallen.com/edge, where you can actually download a guide on how and why to use edge computing, or you can continue the discussion with us online afterwards via the email addresses or my Twitter handle there. But again, thank you for your time attending our discussion on the connected battlefield and edge computing. Enjoy the rest of the conference. Thanks.